Let's start first with the adapters. That's, in most cases, the biggest problem. So there are two possibilities of adapter contamination, and we only talked about one. So you can have adapter dimers, yeah? And of course, since the adapter dimers contain the parts that will bind to the sequencing primers, you will generate reads for these adapter dimers. And these reads will consist completely of adapter sequence. You're going to remove them. That's the adapter contamination that we talked about. There is a second form of adapter contamination, and that's what you see here. So, typically, when you make your fragments, you're going to select a certain size range of fragments. And that's typically between 100 and 800, 900 bases. So these are the fragments that you select. Now, this size selection is never perfect, so very often you will also have smaller fragments in your libraries. So when you have very small fragments in your libraries, it can happen that the length of the fragment is smaller than the length of the reads, than the number of cycles that you do. And when this happens, well, the following thing will happen. We add the sequencing primer. The primer will bind to the red adapter and will initiate sequencing from here. So in the first cycles of sequencing, you will nicely sequence the fragment. But then at some point, because the fragment is so small, you will end up in cycles where you will start sequencing the blue adapter sequence. So you will get a read that consists partly of fragment, which is interesting, which is what you want, and part adapter sequence, the blue adapter, which is not what you want. Yeah? So Tremomatic will remove both types of adapter contamination. It will remove reads that consist completely of adapter sequence, and it will try to remove the bases from the reads that come from the adapter sequence. So it will both filter adapter sequences and it will trim adapter sequences. And in this process, having paired end reads is really beneficial. Not so much for the adapter dimers, they're easy to recognize, he will find them in single end data also, but here it's a big benefit. Because if the adapter sequence here, the adapter contamination is small, then it's very hard to say, yeah, it's really adapter, or it's just a fragment that looks like an adapter. If it's only 4 or 5 bases, you will not be able to say with 100% confidence that it is adapter sequence. Yeah? It might be a fragment that looks like the adapter. In this case, when you have paired end data, you will be able to say this with 100% confidence, because in paired end data, you will have more information. So the part of the reads here that come from the fragment will be complementary. They come from one fragment. So this will be the plus and this will be the minus. They will be reverse complements. The part that comes from the adapter will not, because this adapter and this adapter are different. They have different sequences. And the length of the adapter contamination in the two reads here that form a pair will be exactly the same. So you have a lot more information. The part that is okay is reverse complements. The part that is adapter contamination is not. And the parts that are adapter contamination should have the same length. That's a lot more information. So here, with paired end data, you can remove very small adapter contamination. In single end data, you cannot. It needs to be big, so you're 100% sure that it's really adapter.